Assalamualaikum and a very good morning to all my dear students. So for today's lecture, we are going to cover about the other types of chain growth polymerization, which is an ionic polymerization. So look at the lesson outcome first. Upon the completion of this chapter, students should be able to write the initiators for an ionic polymerization, write the chemical reaction mechanism, and derive the kinetics of an ionic polymerization, describe the leaving polymerization, explain the advantages of leaving polymerization, and the last one, explain the number average degree of polymerization. So previous lesson, we have covered about the mechanism, the initiator in the free radical. So in this subchapter, we will cover the mechanism of an ionic polymerization. So, for the introduction, structural requirement in an ionic polymerization, many monomers can polymerize by more than one mechanism. So, the statement is a general statement whereby monomer, which is, for example, polystyrene, it can be polymerized by free radical. It can also be polymerized by anionic. So it not limits to one types of polymerization technique only for certain polymer. The polymerization mechanism best suited for each monomer is related to the polarity of the monomer and the Lewis acid-base strength of the ion formed. Monomer in which electron-donating group are attached to the carbon atom with the double bond. For example, isobutylene are capable of forming stable carbonium ions. For example, they behave as Lewis base. Such monomers are readily converted to polymer by cationic catalysis, which is as Lewis acid. So basically, an ionic polymerization involve the monomer with strong electronegative substituent. So it polymerizes in the presence of carbon ion. For example, of polymer that can be polymerized by an ionic polymerization is styrene, diene, acrylate, methacrylate, aldehyde, bauxite, acrylonitrile, and cyanoacrylate. So basically, the initiator have charge, which is an ion, which is negative charge. Okay, so we'll look at the next slide. Comparison between an ionic and free radical polymerization. So first, it has no chain termination by combination. Since the growing chain, which is macroion, repel each other electrostatically because of their similar charge. So, chain termination occur only by reaction of the growing chain end with substance such as water, alcohol, acid, and amine. The ion produced by reaction of this substance can sometimes initiate new chain, which is chain transfer. Okay, production of living polymer. Under certain conditions, the ionic propagation species can retain their ability to grow over extended periods of time, even after complete consumption of monomer. So, the living polymerization we will cover at the end of this chapter, whereby living polymerization only can be produced by ionic polymerization, which is chains remain active unless there is deliberate termination or chain transfer. So it will affect two important consequences. For example, the molecular weight or the number average molecular weight, and also um, the MN. Okay. So for example, leaving polymerization of styrene butadiene rubber we can produce styrene butadiene rubber by leaving polymerization, which is styrene butadiene rubber produced with no termination by combination. Alright, third one, ionic polymerization proceeds stereospecifically, which is producing tactic polymer. So tacticity, which is isotactic, syntactic, and atactic. Okay. Fourth, proceed at high rates even at low temperature. So since the initiation and propagation reaction have only small activation energies. For example, isobutylene is polymerized commercially with boron trifluoride, which is BF3, in liquid propane at negative 100 degrees C. So the polymerization temperature often has a considerable influence on the structure of the resulting polymer. So characteristic of an ionic polymerization is rapid at low temperature but slower and less sensitive to changes in temperature. So the response towards temperature is less, okay, compared to free radical. Okay, free radical is very sensitive to heat. So reactions rate depends on dielectric constant of solvent, resonance stability of carbon ion, electronegativity of initiator, and degree of solvation of ligand ion. The next one, independent with temperature, the rate of polymerization slower than cationic polymerization, and the reaction faster at low temperature than cationic polymerization. No formal termination step, but sensitive to impurities, which is carbon ion are neutralized by water, alcohol, carbon dioxide, and oxygen. Termination by ion pair rearrangement does not occur because it requires the highly unfavorable elimination of a hydride ion. Furthermore, the alkali metal counterion used have no tendency to combine with the carbanionic active center to form unreactive covalent bond. Thus, in the absence of chain transfer reaction, the propagating polymer chain retain their active carbanion and group. So for me, an ionic polymerization is more easier compared to free radical. Okay, an ionic polymerization are chain growth process in which the active center to which successive monomer are added is a negative ion that is associated with a positive counter ion. So for the initiation, it also involves the initiation, propagation, and also termination. So typically counter ion is an alkali metal cation. So an ion, an atom or group with a negative charge and an unshaped pair of electrons. So basically the initiator will be dissociate to form positive and negative charge. Okay, so um, the carbon ion, the active site that initiator contain the negative charge is on a carbon atom. This is the reactive site that we react with other monomer in propagation step. And ionic polymerization has tremendous commercial importance because of its ability to control molecular structure during polymerization. This is some monomers that can be polymerized and ionically. This is ethylene oxide or a structure with epoxide group. Okay, look at the type of initiator. First, it can involve any strong nucleophile. So the nucleophile include the Grignard reagent or covalent or ionic metal amide, alkoxide, hydroxide, cyanide, phosphine, amine. Okay, and the second one is the organometallic compound like N-butyl lithium. This is the structure for butyl lithium. So it has 4 carbon atom and 9 hydrogen together with Li here. So the Grignard reagent is actually an organometallic chemical reaction in which the alkyl, so we can refer the structure, which is the alkyl, vinyl or aryl, containing the magnesium. Okay, this is magnesium with the halide, which is the bromine, chlorine or iodine, add to a carbonyl group. For example, we have here is the aldehyde or ketone. So it is the very important reaction to the production of alcohol, whereby during the process of Grignard reagent, the formation of carbon-carbon double bond is increased. Okay. Look at here, we have 1, 2, 3 carbon. It will add with the carbonyl structure here, carbon at the aldehyde structure here. So nampaklah pula dia akan produce 5 carbon atom. Okay, 5 carbon atom which is form of the alcohol. Okay, so don't worry too much on Grignard reagent because we will only use organometallic, which is butyl lithium only in this reaction. Okay, reaction mechanism also involve the ionization, propagation, and termination. For ionization, it is the formation of active center, which is the carbon ion, and the addition of monomer to the active center. Propagation, addition of active monomer to another monomer molecule, and the termination is by chain transfer. Okay, this is the ionization step, which is the formation of carbon ion. Right, this is the structure for butyl lithium. You can write the structure for initiator, which is butyl lithium. You can write in this form, which is Bu with the negative charge and Li with positive charge. Otherwise, you can use this structure CH3, CH2, 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 Li, or otherwise you can use that C4H9 structure. All are accepted. So when react with monomer, which is styrene, it will produce Bu. Okay, butyl structure is attached to the styrene structure without the presence of double bond. It only become a single bond. So just copy the structure of the monomer here. Don't leave the negative carbon ion. Okay, so Li will place at the end of the reaction with positive charge. Okay, so Bu will attach the monomer while Li will at the back of the reaction. During the ionization process, the addition of the butyl and ion to styrene produce carbon ion at the head end. Okay, in association with the positively charged lithium counter ion. The chain propagates by the insertion of additional styrene monomer between the carbon ion and counter ion. So if the starting reagent are pure and if the polymerization reactor is purged of all oxygen and traces of water, propagation can proceed indefinitely or until all monomer are consumed, which is the called as living polymerization. So basically anionic polymerization must be done without water, okay, so that we can produce living polymerization. So otherwise, if a reaction react with water, it will destroy the reaction.